Hello friends, let's start our studio, and in this video I will discuss swapping, sorting, median and quartiles. Now we will study swapping two variables. Swapping means interchanging. Suppose we have two variables, say x equal to 2, y equal to 3. Using a third variable z, we will just interchange the variable values. That means y equal to 2 and x equal to 3. The algorithm is first z equal to x, then x equal to y, and y equal to z. It means z equal to 2, then x equal to 3, and y equal to 2. So basically, we start from x equal to 2, y equal to 3, and we get x equal to 3, y equal to 2. Suppose there is a vector a equal to 2, 3, then a1 equal to 2, a2 equal to 3, and after swapping this we can get a equal to c 3, 2. Now we will do this swapping algorithm using R programming. The swapping idea already shown in the right side so that we can do the program more efficiently. First we will take two variables a and b with values 8 and 6. Then we will use certain criteria to swap them. Without using if loop, if we just write line number 3, then we can also swap the values of a and b. And in this program we are checking if a is greater than b, then only swap. This step is very useful when we perform sorting algorithm. In the output we see the values of a and b swapped as a greater than b. Next we will discuss the sorting algorithm of a vector x using bubble sort. In this example I have taken the length of vector x is 11, that means n equal to 11. Then I used two consecutive for loop where I runs from 1 to n minus 1 and j runs from 1 to n minus I, and check two consecutive elements. If it follows certain inequalities, then swapping these two elements. Now I will illustrate this by giving an example. Here say n equal to 11, that means I will go 1, 2 up to 10, and for each I, j runs from 1 to n minus I. That means when I equal to 1, then j runs from 1 to 10. When I equal to 2, then j runs from 1 to 9, and so on. So here when I equal to 1, then x1 greater than x2. If it's happened, so x1 means 7 and 22, whether 7 greater than 22 or not. This if condition doesn't hold, so we will not swapping these two. So that means j equal to 1 will looks like this. Again for j equal to 2, next two element, so 22 and 13. So there will be some kind of inequality exist. That means 22 greater than 13. This is true. That means swap these two. So as, let's see here, as 22 greater than 13, so we will swap. So like this, j equal to 2. This again for j equal to 3, we will check these two. So there will be no swapping. Again for these two, there will be swapping, and like this we will ultimately get after j equal to 10 this vector, the greatest element at the end. This will be fixed for the entire simulation. When I equal to 2, then for j equal to 1, again we will check these similar kind of ideas, and ultimately we will get last two elements, which will be 37 and 24. And using this algorithm, ultimately we will have our sorted array or sorted vector x. Now we will do this in R programming. Here the ideas we have discussed is shown in the right side. We take a vector x for sorting, then denote n by its length, then writing the consecutive for loops for I and j, and then we will use if condition and check whether xj greater than xj plus 1. It means the jth element is greater than the next element or not. If the jth element is greater than the next element, then we will swap these two elements. The basic idea is we will put the greatest element at the end, and after completing the whole loop on I and j, the elements of x automatically sorted in increasing order. So after running the code, as we can see, the x vector is already sorted. However, in line number 12, instead of greater than sign, if we change it to less than sign, then the vector will be sorted in a decreasing order, as we can see in the console. Now we will discuss median of a vector x. Median means middlemost value of that vector, and there will be two cases arise, odd and even. If x is odd, then the idea is first we will sort x, and we already know how to sort a vector and find the middlemost value. For odd case, there will be exactly two halves around 6 if n equal to 11 here for the illustration. What is n by 2? N by 2 is 5.5. Now we take the ceiling function, that means 6, and x 6, or in general x of ceiling n by 2. Ceiling n by 2 is your median. And if n, that means length of x, is even, then there will be two indices, so x6 and x7, and the median will be x6 plus x7 by 2. And in terms of n, x n by 2 plus x n by 2 plus 1 by 2. We can also denote median by q2. So here we will use the previous sorting algorithm, more specifically the increasing one. Once the vector x is sorted, then we will try to find out its middlemost value. So there will be two cases, even and odd, and in both cases we have already discussed what will be the indices. So we will just implement this in our program. In line number 29, we are checking whether the vector is even. If it's even, then we have already implemented the median in line number 30, and otherwise it's odd, which is shown in line number 32. So after running the code, we see the median is 18. Similarly, if we change the vector x and run the code again, we can see the median value changes. As the length is even, it's the average of middle values 17 and 18. Next, we will discuss quartiles using sorting algorithm. In median, just divide the whole data into two parts, and this point is known as Q2 or median. If we again divide these two, then this is Q3 or third quartiles, and this is Q1 or first quartiles. That means we are dividing the whole data into four parts. There are first quartiles, second quartiles or median, and third quartiles. Here I have taken only the indices and illustrate these ideas. So here the vector has 10 indices or length of 10. Here length of 12, length of 14. That means all are even, and here I have taken the odds, and I will discuss all the cases one by one. If we take n equal to 11, that means n percentage 4 equal to 3, that means remainder is 3. That means we are discussing that case. Here the median is 6, that means ceiling of n by 2, and n by 2 is 5.5 and this is 6. Median is 6, and first and third quartiles are 3 and 9, which ceiling n by 4 and ceiling 3n by 4. Next, if we take n equal to 13, so second case, and we will get 7 as median, that means ceiling n by 2. This is also our 7, and here the first quartile have two elements, means average of third and fourth, and we will have ceiling n by 4. So n by 4 is our 3 point something, and ceiling of n by 4 is 4, and n by 4 minus 1, that means 3. So third and fourth element, their average, and similarly we can have the third quartile also. In a similar way, you can just go through that table and easily understand how we are just finding all those quartile values when the remainders are 0, 1, 2 and 3. Sometimes we also need to find interquartile range, or we define it by IQR, which is Q3 minus Q1. We can easily find this interquartile range. We again use the same sorting code, and then we will implement the quartile coding. Now using the table, we will implement the quartile programming. First, we will implement the case when n is divided by 4. That means n percentage 4 is equal to 0. So we have already written the expression of q1, q2, q3 in the table. So we have just implemented them in our code. Similarly, when n percentage 4 equal to 1, that means remainder is 1. In a similar way, we completed the case when the remainder is 2. That means n percentage 4 is 2, and the case when the remainder is 3. After that, we create an output vector of quartiles. then interquartile range Q3 minus Q1. After running the program, we see quartiles and interquartile range. If we change the input vector x, then get a different value of quartiles and interquartile range, as we see in the console. Thanks for watching.